Hello, I'm playing with junk again, and this time it's really junk because it's broken, it's kaput, it's not working and it's not designed to work, and I'll show you why. So what I have here is a so-called shake flashlight. It's a flashlight that's working without batteries. There is a big magnet here that goes, well, you see it's a magnet indeed. It's a bit difficult to have it around other magnets. That goes inside this tube, and the tube is inside the flashlight body here, and when you shake it, the magnet moves through that coil here and creates some voltage or current or both. The problem is there are some good features here about this flashlight. For example, it's 100% watertight. Well, not now anymore, but there was absolutely no opening, no screw, everything was glued together, and it was one piece of plastic here, so you can literally throw it into the ocean, recover it 50 years later, and there is not a single drop of water inside. But that doesn't help if it doesn't work. And why it's not working, so I will show you that now. Now that's the entire electronics here. We have an LED. That was the original LED. I have already replaced that because that one is broken. And it has a big capacitor. That was the original capacitor, which is also broken. And as you can see, it is not marked. I don't know how many microfarads or volts it has. From the size here, I would say it's a super cap with about 1 farad and probably 2.5 volts. But there is the first problem, because this is a white LED and that needs about 3.8 volt, maybe 4 volts to glow up. There are super caps with 5 volts. But even if that is true, maybe it's just a normal cap with well, a couple of 100 or maybe 1000 microfarads. I replaced it with a 4000, oops, that was the magnet, with a 4700 mic, and here it is, 4700 mic, 16 volts. Now, as you can see, there is not much on the board. There are 4 diodes, capacitor, LED, and a tiny reed switch. That's a switch that reacts to a magnet. And that's the actual switch slider, which is placed here outside on the case. And if that slides up, the magnet here comes near that switch, turns the switch on, and if you slide it down, it will switch off. So, and that's why it is 100% watertight, because the switch here is outside the plastic body. The reed switch, or the mechanical switch, the reed switch, is inside the body, and there is no physical contact, only magnetism that switches that on or off. And everything else is of course inside the tube, so you can glue that tube here together, make it watertight, no problem. Okay, before I start with the circuit, I want to point out the mechanical features, because that's something they did right. So if this magnet here is sliding around, if you shake it, you hear it, it bumps at the end. So we have these end magnets here, which I can't get apart. Okay, so that's the ring magnet on either side with a plastic or rubber bumper here. So that's, oops, that's the wrong way. They are placed here at the end of the tube and they repel the big magnet. So they act as a damper on both sides, so the big magnet does not slam into the end on either side. And the other good thing about this lamp is you have a lot of magnets. You have 2 of these ring magnets, and I will show you another trick you can do with ring magnets. Oops, you have that large neodymium magnet here. It's about 3 centimeters long and, well, maybe 2 in diameter. Yes, 2.5. 1 inch. Okay, you have a lot of magnets and you have a crappy electronics, and that looks like this. That's the schematic diagram, and you may probably notice where the first problems are. There's the coil with the magnet inside. You have the 4 diodes which create a full wave rectifier. Then you have a capacitor, the reed switch and the white LED. Now, if the reed switch is open, you can charge this capacitor by shaking the magnet. To which voltage? Well, we don't know. Maybe if you shake hard enough, this capacitor will get too much voltage, and that's probably the reason why this capacitor here failed. This is not a capacitor anymore, it's now a 64 kilo ohm resistor as I measured it. The other question is, if you charge that up to, I don't know, 5 volt, 10 volts, maybe more, you close that switch, there is no resistor, you blow that LED. So if your capacitor here is strong enough, charges up to a high voltage, boom. If the switch is open, you shake hard with the magnet, this capacitor gets over voltage, boom again. So not the best circuit. So the question is now, how much voltage can we get from this shake generator here? So I hook up my oscilloscope to see what it does. As you can see, I set it to 10 volts per division. I have a times 10 probe here, so each division is 10 volts. And let's have a shake. And you see I can easily get up to 15, 16 volts. Yeah, even 20 is possible. I think that's a little bit much for an LED. The other question, of course, is to what voltage will my capacitor be charged up? So I attach my multimeter and we will see what it tells us. Okay, we have now half a volt. That's the rest from the last charge. So I start shaking gently. 4 volt, 5 volt. I can feel there is a resistance when I shake this magnet. 10 volts, no problem. 11, still gets higher. 12, 15, 16, 17, 18, Yeah, 20 volts, no problem. Now it's going down because that's the self-discharge of the capacitor. And now we will try what happens if we close that reed switch. Well, I still have my multimeter hooked on. It still reads 19.5 volts. And now here is my switch magnet. And I go close to that reed switch. Boom. Did you hear that? That was the LED. Pang. We still have 18.5 volts, but the LED is gone. So whatever you do with this circuit, you will either destroy the capacitor because it goes up to 20 volts and that one doesn't look like a 20 volt capacitor. If it does, you will destroy the LED because they forgot to insert a resistor. And I promised I show you a trick with these ring magnets here. No, that's not the trick. Let's say you have a lithium battery like this one, an 8650, and you want to attach some wires to the end. Maybe not permanently, but for testing, for charging, for whatever. Then you take a ring magnet, maybe even a smaller one would work, and you just wind around that wire a couple of times. And also that one here. Maybe a little bit longer would be a good idea, so you can fill up the entire ring here with wire, and then you simply attach it. Oops, that's negative, that's positive, to your battery. And the good thing is you don't have to solder the battery to the wire. The magnet sticks to the battery and clamps the wire between itself and the battery contact, so it makes a good contact even for larger currents. If you take a smaller magnet, it will probably fit a little bit better, and if you turn the wires all over this surface of the magnet, it will find a couple of points where it actually touches the battery and makes good contact. So that's a simple trick, and if you don't need that anymore, you just take it off, use your battery for whatever. You can also connect two wires together if that is necessary. So that's very convenient with these ring magnets. You can also solder the wire end to the beginning to make to prevent the unwinding of the wire. Okay, that's the simple trick with ring magnets and lithium batteries. Thanks for watching.